Hello to everyone. I am Professor Raja, working as Assistant Professor EC Department, SNS College of Technology and Autonomous Institution, Coimbatore. In this YouTube video, I am going to discuss the subject 19 ECB 301 Analog Digital Communication subject under the topic Properties of Line Codes. As you know, line codes means it is electrical representation of binary data streams. Digital digits are mapped to a pulse waveform is called line codes. So whatever the data ones and zeros that are converted into a pulses of positive pulse and negative pulse, that method of representation is called line codes. The important properties of line codes are DC component, self-synchronization, error detection, bandwidth compression, differential encoding, noise immunity, spectral compatibility with channel, and finally the transparency in signal transmission. And now we are going to see the various methods of line coding. The first important is unipolar NRZ signaling. In this line code method, the symbol 1 is represented by transmitting a pulse of amplitude A for the duration of the symbol, and symbol 0 is represented by switch off the pulse. That is why the unipolar NRZ line code is also referred as on-off signaling. The disadvantages of this on-off signaling or unipolar NRZ signaling are the wastage of power due to transmitted DC level and the fact that the power spectrum of the transmitted signal does it affect the original transmission of the system. So simply unipolar NRZ signaling means whatever the bit comes, 0 means there is no pulse is transmitted, 1 comes means positive pulse is transmitted. Next method is polar NRZ signaling. In this second line code, symbol 1 and zeros are represented by transmitting a pulses of plus A and minus A respectively as shown in this figure. The polar NRZ line code is relatively easy to generate, but its disadvantage is that the power spectrum deficiency will occupy more frequency. If you see, 0 means it takes from 0 to minus A, positive 1 means it takes from positive A to minus A. Third one, unipolar RZ signaling. In this third line code method, symbol 1 is represented by a rectangular pulse of amplitude A and half symbol width, and symbol 0 is represented by a transmitting of no pulse. Simply, symbol 1 means a amplitude of pulse with half symbol width, 0 means no transmitting of pulses. An attractive features of unipolar RZ line code is the presence of data function at f is equal to 0 and half dB in the power spectrum of the transmitting signal. The delta functions can be used for bit timing recovery at the receiver. However, its disadvantages is that it recovers 3 dB more power than polar RZ signaling for the same probability of symbol error. The figure 3 shows the unipolar RZ signaling method. Then bipolar RZ signaling. This line code uses 3 amplitude levels as indicated in the next figure. Specifically, positive and negative pulses of equal amplitude plus A and minus A are used alternatively for symbol 1 with each pulse having half symbol width. No pulse is always used for symbol 0. A useful property of bipolar RZ signaling is that the power spectrum of the transmitted signal has no DC component and relatively insignificant low frequency component for the case when symbol 1 and 0 occurs when equal probability. The bipolar RZ line coding is also called alternate mark inversion signaling. So this figure shows the bipolar RZ signaling method. Last method is called Manchester code. This is the final method of signaling in line codes. The symbol 1 is represented by a positive pulse of amplitude A followed by a negative pulses of minus A with both pulses being half symbol wide. For symbol 0, the polarity of these two pulses are reversed. A unique property of the Manchester code is that it suppresses the DC component and has relatively insignificant low frequency components regardless of the signal statistics. This property is essential in some good applications. So in this YouTube video, I discussed what is in by line codes, and line codes is the electrical representation of binary data streams, and some of the properties of line codes are discussed. Then various Various classifications of line codes are discussed, that is unipolar NRZ signaling, polar NRZ signaling, unipolar RZ signaling, bipolar RZ signaling, finally the Manchester code. Next YouTube video I am going to discuss the new topic in digital communication. Thank you for watching my video.